Hello and Assalamualaikum everyone. My name is Intan Patricia binti Rosli with ID number 22006766 and our group will present about methanol production plan. First of all, for introduction for principle of chemical engineering, the concept in this subject is important to use as a guide when chemical engineering is facing some technical challenges. First of all, what is methanol? We can call methanol as methyl alcohol with formula CH3OH. It appears as a colorless, fairly volatile liquid with a faintly sweet pungent odor like ethyl alcohol, but it also can cause blindness, even death, to ourselves. Methanol primarily used as an industrial solvent to help create ink and resins. How can we produce methanol? From this project, we choose the most conventional way of methanol production, which is from natural gas or syngas. It consists of three basic steps, which are production of synthesis gas, conversion of the syngas into crude methanol, and lastly, distillation of the crude methanol to achieve the desired purity of methanol. Also, it can be synthesized from several carbon-containing feedstocks, including natural gases, coal, biomass, or carbon dioxide. First of all, the syngas, which is carbon monoxide and hydrogen, are compressed in the compressor from 150 kPa to 350 kPa. At the mixer, the syngas that exit the compressor will mix with the recycled hydrogen that exit from the top product of the separator. After that, at the heat exchanger, the heat will increase the temperature of the mixture of the gas from 50 Celsius to 380 Celsius, and then it will be fed to the reactor. And then in the reactor, the product from the reactor depressurized to separate the non-converted gases from liquid. 90% of carbon monoxide converts to methanol in this reactor. The reaction that occurs in the reactor is highly exothermic and takes place with a decrease in a volume. Then we will go to the cooler. This cooler will cool down the higher temperature of exit gases from the reactor. The temperature will drop down to the 100 Celsius when it leaves the reactor into the separator. Then we will go to the separator. In the separator, it will separate the liquids and gases that exit the reactor. The liquid methanol is thrown off and the gas will be recycled to the mixer. Lastly, our final unit operation, which is distillation column, is used in this production so that we can distillate the pure methanol and wastewater from the product that exits separator. Since the methanol have a higher boiling point than water, so methanol will exit at the top product of distillation column, and then we will get the pure methanol from the top product of this production plant.
Next is the calculation for mass balance for non-reactive and reactive part. Non-reactive, which is distillation column, this is the flow diagram of distillation column. Firstly, we assume that the feed flow rate is 100 mole per second. For the top product, 99% of methanol is produced and 1% of water is produced. Temperature and pressure for the top product are 80 degrees Celsius and 1 atm. For the bottom product, 100% of water is produced. For the temperature and pressure, 50 degrees Celsius and 1 atm. 0.5 mole of methanol and 0.5 mole of water is given through the distillation column. For the temperature is 50 degrees Celsius and pressure at 1 atm. Next, we calculate the total balance, water balance and methanol balance. Then we get the bottom flow rate and top flow rate. For reactive part is reactor. This is the reactor flow diagram. The chemical equation that we use is CO plus 2H2 produce CH3OH. The output flow rate is 100 mole per second. The number of moles for carbon monoxide and hydrogen are 0.45 and 0.55 moles respectively. For the temperature and pressure for the input is 380 degrees Celsius and 750 kilopascal. For the output, 450 degrees Celsius and 750 kilopascal. Next, we calculate the consumed, generated and output of the process. If the number of mole for the carbon monoxide is 45, it makes the hydrogen 90, which exceeds the limit of the hydrogen, which is 55. Therefore, we choose the number of mole for hydrogen 55 that makes the carbon monoxide equal to 27.5 and CH3OH 27.5. Next, we calculate the output flow rate, which is 62.25 mole per second. Then, this is the final flow diagram of the reactor.
Hi, so I'm going to explain the energy balance for the reactive unit and non-reactive unit. So this is how I calculate the molar flow rate in. So 1 mole of carbon monoxide react with 2 moles of hydrogen gas is equals to 45 moles of carbon monoxide react with 90 moles of hydrogen gas. So as we know, we only have 55 moles of hydrogen gas. So hydrogen gas is a limiting agent because only 55 moles of hydrogen gas is used in this reaction. So we use the 55 moles hydrogen gas equals to 27.5 moles of carbon monoxide. So every 55 moles of hydrogen gas, 27.5 moles of carbon monoxide will be used in this equation. So the calculation will be focused on 27.5 moles of carbon monoxide that is reacted. So N1 will be 55 mole, N2 27.5, and N3 will be 27.5. So for H1, H2, and H3, we just refer B1 table and B2 for the heat capacity, and this is what I got. So we just insert in this equation. So the answer for this equation is 8,713.925 kilojoules per hour. So next is for the non-reactive unit. This is the feed, the upper product, and the lower product. So N1 and N2 both are 50 moles per hour because we assume that methanol and water feed is equal. So N3, N4, and N5 I just take from the 2.3 mass balance molar flow rate. Next, we proceed to the heat enthalpy. So we just refer to table B1 and B2. So this is the answer for the H1 until H5. So we just insert all the values into this equation, and the answer is 108.263 kilojoules per hour. Thank you.
Very good day, to our lecturers. So now I'll be going on the fluid mechanics part of this report. So this will be the layout of piping lines of this project, and we have decided to choose the pipe of 4-inch schedule 40 steel pipe with the internal diameter of 4.026 inches. And in this diagram, we have 4 standard 90-degree elbows, 1 standard T-branch, and also 1 control valve. So the way that we calculated our pressure drop was using the Darcy-Weisbach equation, and with some assumptions that has been made and has been stated in our report, the pressure drop for this piping line has been calculated at 1,650.9064 pascals. So this will be the tank dimensions of our storage tank. The material that we have chosen is stainless steel. This is because stainless steel is very excellent at resistance to corrosion, erosion, and also high temperature. And this is because by using stainless steel, it is to prevent formations of iron pentacarbonyl, as it could contaminate the methanol and promotes higher formation of hydrocarbons, which could cause waxy products. So the strategies that we are going to use from delivering the main product from the final to the storage tank is by using the conservation of mass and the first law of thermodynamics, in which it states that mass and also energy cannot be destroyed nor created. It can only be formed from one form to another form. So the pipe is also connected. The pipe connecting the storage tank is also a stainless steel pipe for the reasons that I've stated previously. And the pipeline is also insulated. This is to avoid heat loss and preserve temperature. Frequent maintenance of the pipeline system is also promoted to prevent leaks or corrosions. For the pump power calculation, these assumptions have been made, and we have calculated our pump power, which we estimated for it to be 4.9005 watt for the pump power. Now, as for the conclusion, at the end of this project, we have learned that many things throughout the process to build and develop a plant methanol so that it can work efficiently. With the concept of principles of chemical engineering, we can find the mass balance and also energy balance that are required in the production of methanol in order to control processing, and particularly in the control of yields of the products. And by using the concepts of fluid mechanics, I found that it is important to choose for suitable storage and dimensions, and also the selection of pumps with the calculation of pump power and also pressure drops, so that the production of methanol, so that we can get a clearer picture of how a plant actually works. And I think that should be it for our group. Thank you.